Here is another question from Resnick Halliday's 10th edition, page number 142, question number 27. The question reads that body A weighs 102 Newton and body B weighs 32 Newton. The coefficients of friction between A and the inclined plane are mu s is that the coefficient of static friction is 0.56 and mu k coefficient of kinetic friction is 0.25. The plane is inclined at an angle of 40 degrees. Let the positive direction of x-axis be along the up the incline. So this is the positive x direction and this is given as 40 degrees. Okay, so there are three cases. We have to find in unit vector notation what is the acceleration of A if A is initially at rest, B moving up the incline, and C moving down the incline. Let's take the case 1 when this is at rest initially. When this is at rest, so the tension T acting on this is like this. So when it is at rest, tension T is equal to 32 Newton. This is from the free body diagram of block B. Now let's resolve forces for block A. So this angle is given as 50 degree. So this and this the weight along the plane will be 102 cos 50 and the vertical is 102 sin 50. So the normal reaction, this n is equal to 102 sin 50. So the static friction that is acting, because the block will tend to move down the inclined plane, so the static friction will act up, and that will be mu s 102 sin 50. So mu s is 0.56, so this becomes 0.56 times 102 sin 50. If you calculate this, this comes out to be 43.75 newtons. Now this friction force will act upwards and the tension is 32 Newton. So total force acting along the positive x direction becomes 32 plus 43.75 Newton. I mean, this is not the force acting. Basically, this is the maximum force that the block has to overcome to accelerate downwards. So this comes out to be 75.75 Newton. So 75.75 Newton. Now the horizontal component 102 cos 50 is equal to 65.56 Newton. So this force is less than 75.75. So the block will not accelerate at all. Okay. So the acceleration becomes 0 when it is when initially it is at rest. Now let's take a case when the block is moving up the incline. Now if it is moving up the incline, we'll take the acceleration up as A. Now the frictional force will act down. Because it is moving, we need to use kinetic coefficient of friction. So when it is moving up, for the block B, the equation will be B minus 32 equal to minus 32 by 9.8 A. Now the acceleration that we have marked is downwards. So that's why this. So T will be equal to 32 minus 32 by 9.8 A. Now for block A, when we will write equation, it will become tension T minus 102 cos 50. So that is 65.56 minus kinetic friction, that is 0.25 into 102 sine 50. This is equal to 102 divided by 9.8a. If you solve these two equations, you will get A as minus 3.88 meter per second square. So we have marked the acceleration along the positive x direction and it is coming negative. That means it is along the down the incline plane. The positive acceleration is down the incline. Now let's take part C, moving down the incline. When we will resolve the forces, now this time the acceleration is down, so the acceleration is marked like this. The block B will move up. So first, writing the equation for block B, becomes T minus 32 equal to 32 by 9.8. The mass becomes 32.98 basically, because it's weight. So this is the first equation for part C, and the other equation will become minus 102 cos 50 plus mu k. Mu k is given as 0.25 times the normal force is 102 sine 50. This is 102 sine 50. And then this is plus 32 . Or basically this is tension plus T is equal to minus 102 by 9.8 A. So you'll have to solve these two equations. This is equation 2. You have to solve these two equations and then you get the value of A as 1.08. That is again negative, minus 1.08 meter per second square. So we had taken the acceleration along the negative x direction and it has come negative. So basically acceleration is along the positive x direction.